Alright, this video is going to talk about how to factor expressions that have rational exponents. And more specifically, when we have rational exponents that end up having positive and negative values. First of all, I want to talk about what a rational exponent actually means. So when we see x to the 1/2 power, we're saying this base can be rewritten as a root of some sort. Okay, so in this case, it's actually the square root of x. And here's where it comes from. This rational exponent represents the power over the root, where the power is the exponent on the piece that is underneath your square root symbol, and the 2, the denominator, is the index value of the root. In this case, a square root, which we often don't see that too. Okay, if we wanted to think about x to the 1/3, that would be the cube root of x, and you would see something like a 3 with those expressions. We're going to often change square roots, cube roots to rational exponents to make them more easy to work with this course. So, now that we know kind of what they mean, let's talk about how to go ahead and factor when we see them. Okay, so your work with exponents have told you that when we see a negative power, it really just means the reciprocal, or that base moves to the denominator of an expression, and that's really important to realize. Okay, so we're going to go through and talk about that as it relates to factoring. So first thing we need to do with factoring is identify how many terms there are so we can look for shared factors in those terms. So terms are separated by plus or minus in the expression, but watch out when you see parentheses smushed with other pieces, either numbers or variables. That means a product is taking hold. So even though there's a plus here, it's grouped with this whole piece. That's our first term. This plus is what is actually separating our entire expression into the 2 terms that we see here. After we identified our terms, we're going to look for common factors. These could be numbers, these could be variables, or they could be entire expressions, often grouped in parentheses. So here we're going to start with our numbers. We've got 9 and 3, and the common factor for those is the number 3, and we'll just write it. Okay, then we see the rest are groups of expressions here with parentheses, and the only thing showing up in this first one is 6x plus 2, and we do see it on the other side. You'll notice the exponents don't match, but we'll deal with that after we write down the 6x plus 2 in our grouping symbols. Okay, so what we need to really remember here is when we are factoring out, we want to pull out a shared factor, which when I talked about this in my last video, meant really we wanted the smallest power. So with ours, 1/2 and negative 1/2, the smaller one is the negative value. We're going to factor out the negative 1/2. And with these kind of messy expressions, I usually use brackets until I've done some more simplifying with the second piece. Okay, so this is what we're factoring out. Now that we've seen what's in common, we're going to actually write what's left. So piece by piece, we've got 2 terms, which means I should have 2 expressions in this part no matter what. So let's go to work. This first piece, 9, factoring is really division, so 9 divided by 3 would be 3. And the division is how we're going to think about this second piece. We have 6x plus 2 to the 1/2 power, and we're dividing it by this thing we're pulling out. So this is our 6x plus 2 to the negative 1/2 power. And because those factors have a common base, we can use our quotient rule. We're going to rewrite that 6x plus 2, and the quotient rule says we can subtract our exponents. So 1/2 minus a negative 1/2 ends up changing that to plus. 1/2 plus 1/2 is 1. So we have a 6x plus 2 to the first power left over. And oftentimes you won't see people write that first power since it's just the 1. Okay, that first piece is done. We're going to use this symbol plus, that's important, and then move on to the second piece. So 3 divided by 3 is 1. You can write that or not, just like we were talking about with the exponent. And then it's 9x minus 1. We can't take anything out of it, so we just write it. The second piece, though, we can use our division, and because they match entirely, just like 3 divided by 3, this 6x plus 2 to the negative 1/2 is being divided by itself, so that is really a 1 as well. Okay, so we usually don't write these 1s when we see things cancel out, as long as there's something there. Okay, but I wanted to really show you what was happening, and that kind of helps visualize the process. So the next thing we're going to do is simplify what's inside our brackets. The rest can just come down for now. So looking at these parentheses here, we know that that exponent doesn't matter, but the parentheses indicate we want to distribute. So still in my brackets, I'm going to write 18x plus 6, and then going to the same thing on the second side would be plus 9x minus 1. And then I can go ahead and combine any like terms that I see in there. Okay, so 18 and 9 is 27x, and 6 minus 1 is 5, and that's all that's left. So bringing down this, we want to look if there's anything else we can do using this. Because there are two terms here, the only thing you'd want to do is look for if there was a greatest common factor that you could pull out. We don't have any like terms between 25 and 7, so there's nothing to factor out that could end up being put together with that 3. So this is really it. And it doesn't matter what order that you write these parentheses in, and oftentimes when we do our final answer, now that it's nice just to 2 left terms, we will end up writing that second part with parentheses rather than our brackets. But again, the order doesn't matter. And that's all. Okay, let's look at another one for practice. Okay, this one is very similar to what you see on your homework, number 19. So, same process applies. We're going to find our terms first. This whole thing is our first term, then the plus sign, and our second term. This is a little bit strange to see the variable with a single term here, expression rather than a plus or minus at the end. So if you want to rewrite it with that in front without the parentheses, that's the more normal way to write these, at least as your final answer. Okay, we don't usually see parentheses on the end with those types of things. We say parentheses for items that are adding or subtracting terms. Okay, so that's more commonly how they are written in standard form, at least when we're talking about making sure they look nice for our final answer. We're not to our final answer, though, so we're going to look at anything in common with these two things. Starting with those first pieces, the x and the 2x has an x in common. And then my parentheses do match, so I'm going to go ahead and write that out. Again, we are using our smallest exponent, that would be the negative 1/2 for us, and then starting on our brackets to see what's left. Okay, I talked about last time, when we're factoring out, we started with 2 terms, we need to see 2 terms here. X divided by x is 1. Okay, so I'm going to go ahead and write that. You wouldn't have to necessarily until this next part. You realize that this matches that, so it's really times 1 again. I don't care if you write the first one or the second one, but in this case you do have to write one of them. We're saying this whole thing divided by this whole thing is the number 1, and you have to have it because it's being added to the second piece, not multiplied. Okay, so we got to say plus, and then go on to the second part. 2x divided by x is 2, and then we're going to talk about this piece. Okay, so remember, it's this first part on top, x squared minus 4 to the 1/2, divided by what we're factoring out. So x squared minus 4 to the negative 1/2. Our bases match, so we've got x squared minus 4, and because we're dividing, we're going to subtract our exponents. 1/2 minus a negative makes plus, and 1/2 plus 1/2 is 1. So I'm rewriting with x squared minus 4 to the first power. Okay, so within these parentheses, I'm going to go ahead and rewrite this, x squared minus 4 to the negative 1/2 power. I've got a 1, then plus 2 times this. I'm going to go ahead and leave off that 1 at this point. And then I just want to chat for a second. A common mistake that I see folks get into here is that this thing right here gets called 3. And what's really important to note is order of operations. when we're going through our order of operations, okay, grouping symbols matter first, then exponents, but here's what's happening. We've got multiplication with that 2, and we've got addition with that 1, and we cannot do addition before we do this multiplication. So this actually will not work to combine right now until after we distribute if we want to. And in some case, distributing is going to make our life look a little easier because our numbers end up canceling out and good things happen, and sometimes it's really not helpful. And it takes practice to kind of recognize when it's going to be helpful or when it's not. Okay, so let's just try it on this one. Okay, this 2 going through here, 1 plus 2x squared minus 8, and then we do have some terms that we can put together here. So this might make it end up look nicer. I'm going to go ahead and bring this part down so we don't forget about it. And then move on to combining these. Okay, so I've got a 2x squared and a negative 7. Putting my x first just because that's usually how things work for polynomials. And then because this just has 2 terms, I'm going to go ahead and switch to parentheses at this point. Then we've got the x and the x squared minus 4 to the negative 1/2. And that's really all we can do for this one because there ended up being 2 terms here. If there's only 1 term, you could combine it with that front part. But in this case, that is all. Hope that helps. If you do have any questions regarding your specific problem that you get on my math lab, please be sure to reach out by email.